Okay. This should, oh yeah, okay. So at the back of your formula sheet, we're going to do the double angle identities. You can ignore the product to sum and sum to product. Won't even go over it. Okay? So this is the last piece. Remember, double check your formulas because this is what you get to use on your tests on Friday. Okay. Okay. Yeah. Well. Okay, so those are the ones you need for your test. You can bring like a separate sheet on your own. Alright, here we go. Double angles. Ready? Okay. First one. Cosine of 2a, or 2 angles. 2 theta, 2 t, whatever. One of the formulas. What? Yeah. One of the formulas is sine squared. No. Cosine squared minus sine squared. Is that the same as sine squared minus cosine squared? No, because in minus, minus the order matters. So the order does matter. Right? So sine squared plus cosine squared, you can switch it. It's the same thing as cosine squared plus sine squared, which is 1, right? When you're adding the squares together, it's 1. But if you're subtracting sine from cosine squared, it's cosine of double that angle. So twice the angle. So for example, if your angle was 30, then double that angle, you get 60. Yeah. Right? It's that easy. Now, sine squared and cosine squared all have alternate forms. For example, cosine squared is 1 minus sine squared, and then sine squared is 1 minus cosine squared. So if you were to replace either one and then simplify again, you could have 2 more identities. So all 3 of those things are, they're just different forms of the same thing. Okay? Okay. Which one do we use? This one? The one that makes more sense. The one that makes more sense. What is left? Follow your heart. Right. So that's the only issue for cosine of 2a is that there are 3 different formulas for the same thing. Right? It does not happen for sine. Sine is actually a lot easier. So the sine of a double angle is just 2 sine times cosine. That's it. 2 times sine times cosine. Right. So for example, the sine of 60, if you were to double that, that would be 120, right? So the sine of 120 would be 2 times the sine of 60 times the cosine of 60. That's how it is. Okay? Okay. Last but not least is tangent. That's easy. Tangent of a double angle is 2 tan A over 1 minus tan squared A. Where are they getting all these formulas? Oh, you get to prove them for your identity. Yeah. I ain't joking around, yo. I love that you were looking though. That was good, Paige. That's good. Did you hear that? No. Okay, so Paige was very close. She said, isn't 1 minus tan squared secant squared? Not minus, plus. So you can't just change that to secant squared. I don't know. It's on your thing. Yeah? It's so easy. Alright. Okay, so just focus on these formulas today. Have them in front of you because we're just going to use these. Just these one. Alright, let's do it. Here we go. Alright, so once upon a time, sine was 8 over 17, and cosine is less than 0. What quadrant am I in? Cosine is negative, sine is positive. You're in quadrant 2. Joy. Okay? Why do you need to know that? It's like, you gotta draw the triangle. Yeah. 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 Quadrant 2. Three triangles. Sine is what over what? It's r. True? So the y is 8, the r is 17. X negative what? Negative 15. Yeah, you do your x, y's, and r's, and then you figure out that this has to be negative 15. You have to find that. Everybody good with finding it? Okay. And if you're not, we'll work together. Okay? Okay. So, the sine of 2 theta. Ready? The sine of 2 theta is the same thing as the sine of 2 sine theta cosine. By the way, okay? Okay. So that's 2. Sine is 8 over 17. And cosine is negative 15 over 17. Joy. Yeah? Cosine is y over r. I'm sorry. I said that wrong. Cosine is x over. Yeah. Right? Just pretend there's a 1 underneath that 2. So you're just multiplying 2 times 8 times negative 15, which is negative 240. Is it 240? Yeah. Over 289. And I don't think that reduces. It does. Surprise me. That's good. That's good. Yeah? Okay. Here we go. Anthony, what is your favorite version of cosine 2 theta? Which one is your favorite? First, second, or third? Not first, second, or third? No. You like the second one? I like it. I like it. So, for this next one, to find cosine, it doesn't matter if you pick this one, this one, or this one. That's good. So he wants to pick this one. Okay, that's fine. Well, first, cosine of 2 theta, one of the versions is 1 minus 2 cosine squared. Right? Okay, I'll go back. Sure, sure. 1 minus 2 cosine is negative 15 over 17. Alright? Squared? Yeah? So 1 minus 2 times, that's 2.5 over 189. Yeah? Here. 289, thank you, love. So 1 minus 2 times 2.5 is 450 over 289. And to subtract this, you need to change this 1 to 289 over 289. Right? Gotcha. Yes, love. Is it 2 cosine squared or 2 sine squared? I don't know. Which one is it? Oh, it's supposed to be sine. My bad. Alright. So we're going to change this to sine. I'm sorry. And this will be 8. I apologize. So, not negative 8. So it's just 8 over 17 squared is 64. My bad. 2 times 64 is... Hello? 128. Yeah, thanks, Paige. You are the bomb. No. 289 minus... Yes, no, I had the formula wrong. So cosine 2 is 1 minus 2 sine squared. Sine is 8 over 17. 64 over 29. 2 times 64 is 15. Yeah. So I should have this should have been a sine right here, right? And then so 8 squared is 64. 2 times 64 is 15. Yeah. And then 289 minus 148 is that's the one. So this is 160. Okay? Okay. Alright, and on your notes I didn't put the tangent, so we're just gonna hold on. Thank goodness. You sure you don't want to do it? Because it's kind of fun. It's kind of fun though. Oh boy. Need to do a tangent? You got room on your paper? Just literally plug it into the formula again. Yeah. Oh. It's all good. We can do that back. You want to do that? No, we're good. We're good. Alright. Okay. Here we go. Wow. This one is going to have 6 steps. Okay? Because it's find all 6 of theta. So here's the deal. You're given 2 theta. You have to find theta. Okay. If cosine of 2 theta is a negative and we're between, oh well, it doesn't matter. Between 180 and 270, we're in quadrant 3, right? Okay. So here we go. Cosine of 2 theta is equal to negative 12 over 13, right? Okay. Let's reuse that formula that Anthony picked out. True? This is 1 minus 2 sine squared, right? It's also white. If you pick the first one, you'd have both cosine and sine, which is different. Okay? It's all good. Alright. If we switch places with these 2 things, this one and then this one, right? Then you would get 1 plus 12 over 13 equals 2 sine squared theta. Right? To add those fractions together, change 1 and 2. Yep. Just change to 13 over 13. 12 plus 13. 25 over 13 equals 2 sine squared. Now what? Divide by 2. Now when you divide by 2, you just multiply the 2. Right? So it's 25 over 26 equals to sine squared theta. So, just be 5 over the square root of 26 cosine theta. Is it the plus or the minus? It's a minus. Okay. Well, if we have sine, what else do you have? Yep. Cosecant will be negative root 26 over 5. Right? So there's 2 of them. Now to find the other ones, what can I do? If not, I just left it up. That's all. Honestly, great. You get to college. Oh, we plug 2. Right? We plug 3. Right? So sine is negative, we plug 3. Okay? Okay. So, yeah. Yes. Yes. You could do that, but since we've been doing triangles all day, let's just try to do it. Yeah, let's do it. Let's do it. Alright, sine is negative 5 over root 26. Right? 26 minus 25 is 1. So this would just be negative 1. Right? And x squared, y squared, r squared is negative that. So, you should get everything else. Here's the cosine. inverse of 6, which means secant is 26. Very good. Which means tan is, yeah, negative 5 over negative 1 is just 5, which means cotangent is 1 over 5. And there's the other 4. Or use the fundamental identities. At this point, I don't care. Use triangles and identities. Whatever. I'm good. What's that? Yeah. Yeah, you have to find the pieces and then just get it off the triangle. Because tell me what they are. Oh gosh, here we go. Yes, love. Question. Oh, okay. Because there's a proof of it. Oh. 2 steps. It's literally 2 steps. Okay? This is ultimate strike. What I'm going to see today, but I'm very excited. Here we go. No, I will tell you I said I. Oh. Ready? Just not be going too fast. Alright. Does anyone see the dose? Where? Yeah. Right? This line is difference in squares. So it could be cosine squared beta plus sine squared beta, and then cosine squared beta minus sine squared beta. True? What's cosine squared plus sine squared? And what's cosine squared minus sine squared? Yeah. Cosine 2, when you multiply it together, you get that. I mean, come on! Come on! It's so easy though. So easy. I like that one. I like it a lot. Right. Okay. Alright, last 2 examples and you're on your own. Yay? Alright guys, yes love. Question? You good? Okay. Alright. Here we go. Second, yeah. Alright. Here's the deal. You have to be able to recognize these formulas. If they're slightly altered a little bit, that's okay. You can use a special thing called substitution. For example, we've never seen a 5x before. Never seen a 5x. So let's call it A for Anthony. So let A equal the 5x. Okay? So this formula becomes 2 cosine squared A minus 1. Right? What's that? That's 5, yeah. 5x. Right? And 2 cosine squared A minus 1 is the same thing as A. Right? And at this point, plug it in. So it's the cosine of 2 times 5x becomes 5x. So this is the same thing as the cosine of 5x. Oh, exactly. Why am I so stupid? Oh, okay. I was worried. Yeah. Sine 165 times cosine 165. Yeah. Alright. Let's do J for change. Here we go. Let J equal 165. Right. Okay. Here we go. There's this special formula that says the sine of 2 J's is the same thing as 2 sine J cosine J. Right? So you're look at your double angle formula. Sine of 2a equals 2 sine a equals show you. Because this is almost this, but this is right. So if you divide both sides by 2, you get sine a divided by 2 is equal to sine a cosine of cosine. So now this is the same thing as this. So basically, I needed a formula to solve for this. So now if we plug in everything, J was 165 cosine 165 degrees. Sine of 2 times 165 divided by 2 is what okay? 2 times 165 is oh, because the double angle formula, so it's double angle basically solve. Negative half. So this is negative 1/2 divided by 2. What's negative? Negative 1 over 4 is equal to sine of cosine of 2. Yes. Second? Yeah. Oh yeah. Oh, the last one's fun. Right, small. All right. Last one. Promise. It's good. It's good. I don't know. You're gonna rock paper scissors? Good lord. I don't understand why Trig makes people pee, but okay. Oh goodness. Wow. Any questions? Go on. Good? Okay. Last one. Here we go. Keep in mind the goal, right? We want to solve everything so that we have nothing but just cosine x's. So it says solve for in terms of cosine x. That actually helps in your decision making on which equations to use, right? So when you have those three equations for cosine of 2 theta, you pick the one with cosine, right? All right, here we go. Cosine of 3x is the same thing as cosine of x plus x. Yeah? This is how you do the multiple ones. So we have x plus 2x. Cosine of the sum goes cosine, cosine. So this becomes cosine x, cosine 2x, and if it's cosine with a plus, then it's minus sine x, sine x, right? Okay. We're almost there. I need to change everything to cosine. Let's do it. Here we go. Cosine of 2x. This thing? Which of the three would you pick? The first? Not the first one. First one is cosine squared and sine squared. The third one. The third one says cosine 2x equals 2 cosine squared minus 1. Right? So just transform that one to cosine x. Alright? The minus the sine x can't be done right now. But sine of 2x is x cosine x. Okay? So you transform what you can, and you gotta do a little bit of distributive property. No problem. Cosine times 2 cosine squared. Cubed x. Yeah. Okay. Cosine times negative 1. Cosine x. Right? Negative sine times 2 sine. Negative. Right? And negative sine times cosine would be negative sine x cos. Did I miss something? Okay. Yeah. Oh no, we're good. We're good. We're good. We're good. Yes, love. What did I do? Oh no! Sorry about that. Oh, that's wrong. I know. I forgot. That's a plus. So you just have to multiply it once. Alright, that should be okay. Yeah. Alright. So this should be negative 2 sine squared x cosine x. Yeah. Okay. First one's good. Alright. So this is a cosine, this is a cosine. Sine. So obviously the one that needs to change is this. How do you change sine squared x? 1 minus cosine squared. Right? And then you just keep the negative 2 and the cos x together, and this stuff doesn't change. We just copy. Alright. I suggest you start distributing this. There we go. So you're going to get 2 cosine cubed x minus cosine x minus 2 times cosine x minus cosine x. Almost there. Oh yeah. Fine. There's one more distribution to make. The 2. That's a negative 2, right? So take that negative 2 and distribute everything. So you have 2 cos cubed minus cos minus 2 cos plus 2 cos cubed x. What you see? Cos cubes. How many cos cubes? 4. 4 cos cubes minus 3 cosine x, and they all look calculated. Okay. Before the potty rush. Hang on. Here we go. Today and tonight, you'll be working on, right? Again, the 2 pages to put together. So basically, these were supposed to be tomorrow's homework. I just put it all in one homework. You'll have a homework quiz on everything from chapter 5 tomorrow. Okay? Okay. All right. Here we go. Anthony, quickly. Okay. Sir? I did it a little differently, didn't I?